This is Semantic Web Technologies, lecture number 3, Semantic Web Basic Architecture. Today, we are talking about part 3, how to query RDFS, and we will continue with the SPARQL query language. Up to now, we have learned that with SPARQL, we can define query patterns against an RDF knowledge base, and the RDF graph within the knowledge base will be traversed with the help of these graph patterns that we have defined. But SPARQL is much more than simply a query language. We have already seen that. So SPARQL, besides the query language, is also a protocol layer where the communication with the SPARQL endpoint is arranged and is defined. And on the other hand, SPARQL also defines an output format for the answer of your query against the SPARQL endpoint. And first of all, we want to take a look at this result format, at the output format. So, for example, if you have a simple SPARQL query, the results that are returned from the SPARQL endpoint will be in the form of valid XML documents, for example. So it will be an XML document, as you see here, and the type of the XML document. Here, of course, the SPARQL namespace must be defined. Here is the namespace for the SPARQL results in the document. In the rest of the document, the result of the SPARQL query will be explained. So, as you know, each XML element consists of a header and a body. And in the header of this SPARQL result XML file, there in the header, between the header tags, you will find the name of all the variables that have been used in the query and that will be filled. So the name of all these variables, they also give the name of the columns of the result table. So let's take a look down deeper in the body of the result page. So you first have the header with the variable names, and here then the results of the SPARQL query will be in the result markup keywords. And here in the results you will have single sections for each single result where you have then bindings, which means a variable that has already been cited here in the header will be bound to some value. So we have here the result sections, and within the result sections we have some bindings, and there you see, for example, that we have here the binding of a node of a variable with a name x to a blank node that has here a specific name, or we have here a binding to a variable with the name hpage to a URI, and here the URI is given. Or you will have a binding to a literal to a variable called name, and here you define a literal. And in the literal, you can also define the language tag. So for example, here we have an English literal. Or you can define a typed literal that's here, binding to a variable called age, and you have here a literal that has a specific data type, and the data type here is integer, which comes from the XML schema namespace. So, and here the value of the literal is 30. Quite simple. Or another thing here, for example, you can bind a variable to a mailbox, and here you have the mailbox given as a URI. So you see there are for different type of variables, you will have different types of markup language within the result XML file. And for each variable and each result row, you will have here one result with a binding to each variable. So for each line, you have a result paragraph within your XML document, and within each result paragraph, you have the binding for each variable. So that's it. And this is the way how the result is returned from the SPARQL endpoint, and which can easily be interpreted. So that's all. So you see it's pretty simple also from a program to access a SPARQL endpoint, to receive the result as an XML file, and then to pass the XML file and to interpret it as a table. So it's pretty simple. But SPARQL can even more. So we now know the SPARQL result format. We will also take a look at the SPARQL protocol. But before take a look at the SPARQL protocol, SPARQL is not only a query language or a simple query language. I have more possibilities than just to use the select statement. So besides select and besides the select query, SPARQL allows a more general form of questioning, and it's the ask query. And in an ask query, I simply ask, does some result exist for my query expression? And it checks whether there's at least one result, and the result will be true or false. So if the result of an ask query is true, then this means, okay, there are some results, and at least there is one result. You do this, for example, if you don't need the content of the result, and if you only need the information if there is a result or if there is no result possible, and then it's much faster. And the result will be delivered here as XML or also as JSON. So you also have the possibility at the SPARQL endpoint to say that the result should be passed as a JSON file. Secondly, you also have the possibility to construct an RDF graph from the results that are delivered from the SPARQL endpoint. So you do this with a construct keyword. And what is done here, the graph patterns with variables, they, according to a given template, will then be the output. And the output will be RDF XML or, for example, Turtle. You can specify what you like or what you prefer. And the third variant is here the describe statement. And in the describe statement, you also give a SPARQL query, and the result will be an entire RDF graph, again, with data about the resources you are querying. So it's much more complete information that will be returned, and the returned information will also be RDF XML or Turtle. Okay, let's take a look at a small example for the construct statement. So construct itself defines a template for the construction of RDF graphs. Let's take a look first at the database we are querying here. So we have one prefix, and it's the org prefix for some example namespace. And then we have here two different persons we are referring to Alice and to Bob, and they are connected to some blank node. And we have here, for example, an employee name and an employee ID for both of these persons. And what we are asking here is, for example, okay, this is quite nice, but we want to translate this data to the FOF namespace. And in the FOF namespace, of course, we also have something like names. But what we have to do there is we have to substitute here the employee name with a FOF name to have a FOF output. So what you do here is you have a graph pattern. You are looking here for all patterns that have here the employee ID or the employee name here from our knowledge base. And what you construct is you define a new pattern where you put here the subject from the original pattern and the name from the original pattern, and you substitute here simply the property to the property from your new namespace from the FOF namespace. So in the end, what will be the result of your query will be here, for example, if you define the result as serialized RDF XML, will be here then an RDF file based on XML where you have RDF information about here the content of your database in connection with here, for example, the FOF namespace. And you have here the FOF name for Alice and here the FOF name for Bob, which was in the predefined template of the graph pattern from the construct statement we have looked at before. So this is a simple way to translate from one vocabulary to another vocabulary. So it's for vocabulary transcription or vocabulary transformation, and this is quite handy. So this is a nice thing that I can do with SPARQL, for example. Okay, so we have seen SPARQL as a query language, SPARQL as a query for construction of new RDF graphs, and we have also seen the result format of a SPARQL query. What's missing now is simply the SPARQL protocol. So how is a SPARQL endpoint really addressed? So you do this via HTTP. Of course, SPARQL is based on the HTTP web protocol. So what you need to make a query to a SPARQL endpoint, first, of course, is the web address of a SPARQL endpoint. So you need the URL of the SPARQL endpoint. Then, in the SPARQL endpoint, you have to name all the graphs you want to query. And in the end, of course, you need the query string. That is the green one. And then you can put all together. First of all, you will have the address of the SPARQL endpoint in your SPARQL query, which is nothing else than an extended URI that will be put through via the HTTP protocol to the SPARQL endpoint. So you have here the base part of the URI, which is the SPARQL endpoint. Then you have here the quotation or the question mark, and the question mark, after the question mark, at a URI, there come parameters. And first of all, you have here the named graph that you address, and here you are not able, in the name of this parameter, really to use special characters, like here the slash, for example, or the colon. So you have to take into account that you use here the so-called ampersand encoding. And after the graph that you are questioning, the next parameter, after the ampersand here, is then the SPARQL query expression. And the query, you have here the keyword query equals, and then comes the select statement. And here also the entire statement must be ampersand encoded here, or for example, here for an empty or a white space, you take here the plus sign, and then you have here %3f for some other symbol that is not available in the usual string that can be used, or the usual symbols that can be used for the URI. So the encoding here is a little bit difficult, and of course there are lots of routines that are able to transform a regular string, as you know it, to this kind of encoding, because this is quite popular. So it's no big deal. But you have to take into account that when you are taking a select statement, or if you want to send a select statement, you have to put it here as a parameter within the URI, and then you have to do the encoding accordingly. So this must be a proper encoding. So what happens next? For example, this is our SPARQL select query that we sent within the HTTP protocol, and let's take a look at the HTTP trace of the SPARQL query. So what we have is a GET, or an HTTP GET request. So what we do here is, of course, we have a GET request to a specific SPARQL endpoint, and then we have here the entire query, which is here encoded in that case. And then here we have the host name of the host, where the SPARQL endpoint is located, and the user agent here, for example, is my program that I have called my SPARQL client 0.1. So it's a simple HTTP GET request in the same way you know it. And then, in return from the SPARQL endpoint, you also will get an HTTP response. So this is the SPARQL response of the HTTP response. So HTTP will, in the case your SPARQL query was a success, you will get a 200 code, which means everything is okay. You will receive an answer within this HTTP request. Then you will get a date. Then you will get the name of the server where the SPARQL endpoint is located. And you will get here the content type, which will be application, SPARQL results, and XML. So you are able really to know how to decode the SPARQL result that is transferred next. And then comes the XML document you have queried for. So this is the SPARQL result encoded as XML. And here we have, again, in the header, the variables we have asked for, and here the variable binding. And we can interpret the result accordingly. So much about SPARQL. So if you want to try it out, no problem. There are lots of popular SPARQL endpoints. There is a general purple SPARQL endpoint here, but I would recommend to you, as you have maybe already done it in the exercises, to access the DBpedia SPARQL endpoint, because there at this public endpoint of the large encyclopedia, semantic encyclopedia, DBpedia, you can make a lot of exercise queries and you will get interesting results from that. So another thing here, for example, is the DBLP bibliography. It has also an own SPARQL endpoint here at the Freie University Berlin. Or, for example, you can go to the linked movie database to ask SPARQL queries about movies, which also reflects to the IMDb, which is the International Movie Database. Or you can select interesting facts from the CIL World Factbook that has also a SPARQL endpoint available here at the Free University Berlin. Okay, this is what you can do with SPARQL 1.0. In the next part of the lecture, we will take a look into the future into SPARQL 1.1, which up to now is not really a W3C recommendation, but the recommendation is in preparation. And I will show you what you will be able to do with SPARQL 1.1.